All right, take two. So on the slides for stacks, this slide right here is showing how stacks, multiple stacks, can be used to do very simple evaluation of an expression. What I mean by simple, it has no hierarchy for the operators. Everything's being forced by doing parentheses. And with that, if we're only dealing with doing parentheses, saying we want to carry out a value first, we can actually evaluate the expression left to right, and when we get to the end, we actually have a value. So the slides show snapshots for each character as it's or going down each character in the expression. So what I want to do, or try to do, take two. Oh, I didn't reset properly. Sorry. What I'm going to want to try to do is do exactly that. I'm going to do it sort of real time. And if you look back at the slides, you can see snapshots in time of how I got to that point. And the general idea is when we see an operator, we push it to the operator stack. When we see a number, we put it to the number stack. The only time we actually will stop and do anything is when we get to close parentheses. So when I do get to this close parenthesis here, we'll do stuff. When I get to this close parenthesis here, we'll do stuff. But otherwise, I am just, whoops, it's on my staging area. Otherwise, I'm just going to be pushing onto one stack or the other. So the first one we're looking at is an open paren. So the open paren goes onto the operator stack. I already had my top one here, so I don't need to advance the top. It's there. So then I move to the next character. And this is also an operator. So this operator gets pushed onto the operator stack. Top advances. I go to the next character. This is a number. So the number is put onto the number stack. My top is already there. I'll go to the next character. And this is a plus. It's an operator. That goes to the operator stack. Then I go to the next character. This is a 9. That's a number. That goes to the number stack. And now we're at, okay. Oh, whoops. When I did my number stack, sorry, I forgot to advance top. It's the top. Now I'm getting here to this close paren. And this is where we're going to do stuff. So one thing I'm going to do is I'm going to take a peek at the top of the operator stack. And if what is there is an open parenthesis, then all I have to do is take the value that's on top of the number stack. That's not an open parenthesis it's peeking at. The top of the stack currently has plus. So that means that there isn't a value on the number stack that we can use. What that means, or there's not a number value there, what we have to then do is carry out this operation. So from this peak, we realize we have to carry out the operation. And so we pop from the operator stack the operator. Now, and when I pop, the top goes down. Since this is a binary operator, meaning it needs something to the left and something to the right, I need to get two numbers from the number stack. So I will pop one of the numbers off. I will pop the other number off. So I popped off those two numbers, and we'll actually carry out the math. Well, since it's plus addition, whoops, we'll add the two together. We come up with 15. Okay, let me just toss these aside. Just getting them out of the way for right now. So we carried out that operation, and now the value 15 goes on to the number stack. Now that we carried out that operator, the one that was there, we'll peek again. Is there another operator? No, we just have an open paren, and that means that the value that's on top of the number stack is the value of that parentheses that we're just doing. So that open paren can be, that open paren, I did it again. That open paren can be removed. We're done peeking here. Top can go down. Okay, so now we're going on to the next character, the star. That's an operator, so that goes on to the operator stack. The top moves. We go to the next character, 3. That's a number. That goes on to the number stack. This moves. I go to the next one here. Okay, so this is where I want to peek at the top of the operator stack to see, do we have an open paren? I don't. I don't have an open paren. That means there's an operation I'm going to have to carry out. So I pop the operator from the top. Did it again. I pop the operator from the top of the stack. The top is going down. Let me just push this peak off. We're actually are doing stuff. Oh, I forgot to put my do stuff part here. So we're doing stuff. Actually, maybe I should just back up a little. Yeah, it's a train wreck. Let me just keep going. Okay, so this is a binary operator. That means we need 2 values. So I'll take 2 values from the number stack, and I'll pop the 2 values off. By the way, I'm not being careful with when I'm removing them. Is it left, right, or right, left? If I was doing like subtraction or division, I really would have to be careful that I'm getting the right order. But since I'm just dealing with multiplication, doesn't matter. 3 times 15, 15 times 3, it doesn't matter. So I'm going to carry out this operation, which is the value 45. So I'm just going to toss these out of here. I'm sorry for not doing a proper animation. But anyway, so now that we have that, now that value goes on to the number stack. We peek back at the top to see, is there an open paren? There is an open paren. That means this parentheses is now done. This parentheses is now done. I can remove this operator from the operator stack, and I'm done doing the stuff that I encountered at that close paren. So I move one more character, I'm at the end. So then if we're at the end of the expression, what we do is we peek, make sure the operator stack is empty. It is. If it wasn't, I'd raise an exception. We have an issue. There was an error in the formula. And then I peek at the number stack, make sure there's only one number. There is only one number. So now when I do a pop on the number stack, then this is the value that this expression is going to return. So I did evaluate an expression left to right. I had a number stack and an operator stack. Numbers got pushed to the number stack. Operators got pushed to the operator stack. But when we got to close parentheses, we did stuff, which was look, we peeked at the operator stack to see what's there. So the thing I just stepped through, very painfully, and I do apologize, but the thing I just stepped through is, in a sense, how you would read the slide here, which is showing snapshots in time of how these each of these operations is taking place. So I stepped through in this video, going left to right and filling the stacks. The slides show the snapshots in time. If you're developing a language, then using this simple way of evaluating expression, in other words, don't worry about hierarchy. That multiplication and division isn't hierarchy over addition and subtraction, just parenthesize everything. And by parenthesizing everything, we can evaluate the expression left to right, and then this method can be used for it. So sometimes version 1, if we're developing our own language, version 1 might be just do the simple left to right. Once we're getting things working, then version 2, we can go in and deal with hierarchy. So this isn't getting into that. I'm just trying to show sort of a simple way, or I'm really trying to show the use of a stack. what we're trying to do here. It was just using a simple way of evaluating an expression. Oh, that was a mouthful.